Hello again. We are continuing on with our CA2, that's our class activity 2, where we were looking at the serial data set and we were identifying the qualitative versus quantitative types of data. So now we are looking at the qualitative data, and for this qualitative data I had asked us to make a table and or graph expressing the summary of the data. And let's take a look, and we're gonna isolate just a couple of data sets, and that's the carbs and the potassium. So let's take a look at the carbs. Ideally what we would want to do is like put them in order so that we can get some idea of the largest and the smallest values. So we can just scan through, and I'm kind of seeing 9 here. Now there's an empty spot here. I don't want to call that 0. So sometimes when you're collecting data, there's going to be some holes in the data where it wasn't filled, and so we're not going to assume that those are 0. We're just going to assume that that data is there. So instead of having 24 pieces of data for the carbs, we're only going to have 23. Okay. And so I see that 9 is the smallest, so that's the minimum. And then I scan through again and find the maximum, and I think 21 here, 22 there, so this looks like it's the maximum. So knowing the minimum and the maximum kind of gives us an idea of how to kind of rank this in order. So we have the difference between this, so we can imagine like a number line going from 9 to 22. And a couple ways to try to make a graph out of this is to kind of plot how many cereals have 9, how many cereals have 10 grams maybe, or whatever however they're measuring the carbs, 11, etc. Now there's this 11.5 that I noticed here, and so if we're just going like whole numbers, then I have to somehow squeeze in this 11.5 business. So that gets a little tricky. So what we can do is, instead of just plotting the points with the whole numbers, maybe we can get a range of numbers. Maybe we can go from 9 to 10, and then 10 to 11, and then 11 to 12. But now that I'm writing that, it kind of gets a little tricky, and so this is one of the things that we saw with one of the teams that put together it was a nice idea to put together this layout, but we're a little bit overlapping. So to avoid the overlap, instead of doing 9 to 10 and then 10 to 11, maybe just stop short a little bit of 10. So maybe go 9 to 9.9 or something like that, where we don't have to go all the way up to 10. And then the next number would be 10, and they're no longer overlapping. But I don't want to go all the way up to 11, so I'm just going to go a little bit short of 11, 10.9, for example. So sometimes this is what we need to do, and especially if there's like a 0.5 that's showing up there. So that could be the way we can make our table. Now if we do this in this particular way, I got 9, 10, 11, 12. I have to go all the way up to like 22, and so maybe that might be too big for me. So instead of attacking it that way, maybe I want to combine these two things. So 9, 10, and 9 and 10, put those together, and then 11 and 12 and put those together. So in other words, maybe we'll make a table that goes from 9 to 10.9, and then we're going to go from 11 to 12.9. And then if we fill this out, we won't have that many of these bins, we're going to call them, or sometimes they call them classes. More formally, they're each bin is called a class. And so we have 9 to 10.9, and then we have 11 to 12.9. So we can, if we follow a pattern, we can kind of see what's going on. So I would guess the next one is going to be 13, and then the 14 to 14.9, etc. So one way to design this and go a little bit faster is to know what is the difference between two different classes, two different bins. So I'm going from 9 to 11, 11 to 13, so it looks like I'm adding 2 for each one. So maybe I can just fill this in and add 2 to 13, so that's 15, 17, 18, 19, 20, 21, and I think that should be good enough. So I added 2, and I can do the same trick for the upper bounds for these things. I have 10.9, I added 2, I got 12.9 and 14.9, so maybe I just have to keep adding 2 to that. So this is 15 to 16.9, 18.9, 20.9, and then 22.9. So those are my values. So by the way, the steps that you take here when we go into +2, 2 is called the class width. Class width. And that is like the space between each of those bins or each of those classes. All right. So now I can create, this is going to be your carbs, and then we're counting how many cereals would have carbs between 9 and 10.9. So we're actually counting the frequency. Okay, so I'm gonna go down the list and look for carbs that are between 9 and 10. So there's 1, 2, there's only 2. So I'm going to cross it out because once I cross it out, I know it cannot be in any other bin. So it has, those are the only cereals with carbs between 9 and 10.9. Now I go look for 11 to 12.9. So that includes 11, 11.5, and 12. So that's 1, 2, 3, 4, 5, and that's 5. And then between 13 and 15, or 14.9. So 13 and 14.9, that's 1, 2, and there's only 2 of those. Between 15 and 16.9, so that's 16, that's 15 and 16. That's 1, 2, 3, 4, 5, 6. There's 6 of them. And between 17 and 18.9, so 17 and 18, 1, 2, 3. Between 19 and 20.9, so that's 19 and 20. I don't see, I see there's 1, and there's 1. I think I missed the 13.5, so I'm going to go back. 13.5 is here, so I'm going to remember that, and I'll say this is actually 3. So that brings that to 3. And then now 21 and 22, so it should just be the leftovers. So that's 1, 2, 3, and that's it. There's only 3. Now, just to make sure, I want to add this up and get the total, and I notice again that this is missing, so instead of 24 cereals, I should have 23. So if I add this, 2 plus 5 is 7, plus 3 is 10, plus 6 is 16, 16 plus 3 is 19, 20, 23. So 23, that checks out, and we've captured everything we needed to capture. So this is a frequency table. Now from here, you can find a percentage as well, and I won't go through that, but let me just kind of start some basic steps here. When you do a percentage, you can it's actually called the relative frequency. And what you need to do is you need to take your number, your frequency, and you divide it by the total. So that's 23. So 2 divided by 23, I don't have my calculator ready. I will type 2 divided by 23, and I get 0.86. So I probably want to round off to the nearest percentage. So that's 8 point. Well, let me write this down first. 0.0869. So approximately 0.0869. So written that as percentage, I'll move the decimal place 2 units or 2 steps to the right. I'm going to get 8 point, and then I'm just going to round off to the nearest tenth in the decimal place, so that's 6. And 9 is bigger than 5, so I'm going to add 1 to 6, that's 7. So 8.7%. And then I'll do the rest for that, or you can do the rest for that. So that relative frequency table can help make like a pie chart or something like that. But the bar graph that is involved in this numeric data in this particular frequency table is a special type of bar graph, and this is a bar graph for numbers, and this is called a histogram. So histogram is a special type of bar graph that is based on the numbers. So the x-axis, or the horizontal axis, will contain these numbers. So 9 to 10.9. So maybe I'll start here, say 9, and then a little bit short of 10.9 is 11. So I'm just going to put 11 here, but I'm going to say 10.9 is that number right before that. So I'm going to make a bar between 9 and 11 here that would represent my first class, and this is my first class here. So I know my largest is going to be 6. So if I just kind of make tick marks here, 1, 2, 3, 4, 5, 6, and I know that for my first class I have a frequency of 2. So I'm going to go 2 units up from 9 to 11, which is, I'm actually looking at a little bit less than that 10.9. And then from 11 to 12.9, so that's essentially 13, 14, 15. And so count by 2s again because that's our class width. 17, 19, 21, and we went all the way up to 22.9, which is kind of like 23. And then from there you can just make your counts. So the second class has 5. That's 2, 3, 4, 5. So I'm all the way up here. And the next class over here between 13 and 15 is 3. 1, 2, 3. And then 15 to 17 is 6. That's the tallest one. And then 17 to 19 is 3. And then 1. And then 3 again. So this is called a histogram. Okay, so that's how you do it. Now, how do you figure out the class width and things like that? It kind of depends. Generally, you want up to 1, 2, 3, 4, 5, 6, 7, like between 5 to 10 classes. So there's systematic ways of doing things, and then you can set it to whatever you want to or need to set it. But generally, you want somewhere between 5 to 7 classes so that your bar graph isn't too large where you can't really tell what the data is saying, or it's too small and those intervals are too small and it looks like you're just looking at each individual piece. So what I'm going to do now is we're going to take a look at a data set on potassium. And instead of doing it by hand, which you certainly can do, I'm going to pull up our serial data in Google Docs or Google Sheets. And so we are looking at potassium data here, and that is our potassium data. And what we're going to do is we're going to ask Google Sheets to do the work for us. So we're going to say insert, and then we're going to say chart. Now again, a lot of times they give you a default chart, which for the qualitative data that we saw before when we were making bar charts, that's fine. This is essentially a bar chart of every number that's involved. And this is not very useful to me or to anybody looking at statistics. And that is because this is not the type of graph we want. We want a graph that has information about kind of making a histogram where we can group a bunch of numbers so we can see generally what's happening. So if you go to column chart and look for the different chart type, there are the suggested chart types, which is like dealing with qualitative data in general. And there's some line graphs over here and some other column charts that would be useful. But if you go down here, this is the histogram that you want. So it falls under the other category in Google Sheets, but this is definitely the one you want. So if I click on this, what it does, it lays out the information according to what they think should be the class sizes and stuff like that. So here they went with going from 0 to 50, and then 50 to 100, and 100 to 150, etc. And we have 5 classes, which is fine, which is great. But if you want to make that finer, you have control over setting this up. And I think we can do some sort of customization for the histogram. And here is the bucket size, or the bin. It used to be called the bin size, now they call it bucket. And the bin size was automatically set to 50, it looks like. But if we want a smaller bin size like 25, you can see that this goes from 0 to 25, 25 to 50, and then you see a slightly different representation. And then, of course, you can break it up to smaller bin sizes, and maybe having the bin sizes a little too small would make this a little bit less informative for us. And we can see that here we're breaking down the bin sizes by 10, and then we have too many classes to deal with. We got 25 classes to deal with, so that's too much. And so let's bring it back up to 25. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I counted 7, 8 here, even though there's 0, because they're kind of part of the set. So this is okay. We have 9 bins, but I think I did mention between 5 and 10. If we take a look at the original setup that they had, you can see that there's more cereal that have less potassium, and then less and less cereal that have higher potassium counts. So that, to me, is a little bit more meaningful in terms of getting some information about the potassium data. Okay, so this is Google Sheets, a nice way to find the histogram. And if you kind of missed how I got the histogram set up, you can rewind the video and take a look again, and then maybe try it for other pieces of quantitative data, maybe the carbs, the fat, the fiber, and stuff like that, and play around with it to see what kinds of shapes of graphs you're able to see. Okay, so that is essentially the topic or the information that's covered in 1.3. So I hope that will help. in you navigating through 1.3. There's a few more finer details that I didn't go over in this video, but you can certainly find it in other videos that I've provided. And then, yeah, hopefully that'll work out. Okay, good luck. I'll see you in class.